Hi everyone, thank you for participating in the event this afternoon. I'm Yeyoung, a second-year PhD student in the Department of Agricultural, Food and Resource Economics at Michigan State University. It is such a privilege to be part of the session of Climate Change, Gender and Agriculture, a Cultivating Equality 2021 with many experts in this field. I'm going to present a study published in Applied Economic Perspective and Policy this year. Bellew Hailey, Kawajari, and Greg Seymour Avery have contributed to this research as co-authors. Claudia Lingler, Elizabeth Bryan, and Zhao Ku from Avery also provide helpful suggestions and comments on this study. I'm going to share some major findings from our paper. The heat never bothered me anyway, gender-specific response of agricultural labor to climate shocks in Tanzania. As magnitude, intensity, and frequency of climate-induced risk will likely increase in Sub-Saharan Africa, substantial research has been developed on the multidimensional effects of weather shocks on the poor and vulnerable facing acute food insecurity. In following the trend, a large body of empirical research examines the effects of weather shocks in developing regions on outcomes, such as agricultural production, productivity, technology adoption, and household consumption expenditure, nutritional outcomes, and migration. However, fewer have focused on how climate shocks affect men's and women's labor supply in agriculture. This is a knowledge gap this study attempts to fill. As widely accepted in existing literature, women play an important role in agricultural production and household food security, particularly in Africa. In case of Tanzania, women devote about twice as many hours as men to domestic tasks, including food preparation, the collection of water and firewood, and childcare. A growing body of research has shown that men and women have different vulnerability to climate-induced risk. GCON team at Avery developed a gender and climate resilience framework, which helps us to capture gender difference, such as access to and controllable resource, different socioeconomic opportunities, as well as social norms. We can highlight that the effects of climate shocks can affect men and women differently, and gender difference can increase women's vulnerability to climate risk and limit their adaptive capacity to climate change further. To shed more light on this issue, we examined gender-specific response to heat stress and agricultural labor, disaggregated by key agricultural activities, including land preparation and planting, weeding, and harvesting for different household types, including dual adult versus female-only household. Dual adult household is defined as a household with both male and female members, and female-only households with only female members. In this study, we used Tanzania National Panel Survey called NPS and climate data. There are three rounds of this survey. The sample for this survey is composed of 1,913 panel agricultural household, and we focus on agricultural input data report for the long rainy season covering March to May. The data were merged based on geographic positioning system GPS coordinates. We created temperature and rainfall data for the maize growing season. We use daily temperature and the concept of growing degree days, GDD, to construct an indicator of heat stress. The basic concept of GDD by Snyder is that there is a crop-specific temperature range conducive for maize. Schranker and Roberts later identified the critical temperature threshold for maize in the United States to be 29 degrees Celsius above, which there are harmful effects on plant growth and yields. Given the dominance of maize-based systems in Tanzania, we use 29 degrees Celsius as a single threshold to define heat stress. Exploiting the panel structure of the MPS, we estimate a fixed effects models as shown here. This model is designed to control for unobserved time variant characteristics and heterogeneity, and it estimates for each type of labor, male versus female, family versus hired, and each activity. Robust standard errors clustered at the enumeration area level. This table reports some descriptive statistics by household composition. Here we only show agricultural labor. Female-only households use higher female family agricultural labor, which is more than 5 times that of dual adult household. We don't show the rest of the table in this slide, but in our case, on average, dual adult households show higher adult female education than female-only household. Land-owned area by dual adult household is about 1.5 hectares, while female-only household owned 0.9 hectares. This table shows fixed effects estimates on total male and female family labor that control also for district fixed effects. For each full-day increase in heat stress during the maize growing season, male family labor supply declines by about 1.4 days per hectare with no significant effects on female family labor. We also report fixed effect estimates for different family labor activities. As you see in the table, while males marginally decrease labor supply when exposed to stress, females show no statistically significant effect. Fixed effects estimates for higher labor show is stress to reduce both male and female higher labor, relatively stronger effects on the female higher labor. This result in line with the heterogeneous effects of weather shocks on labor, highlighted by previous research. And with the choice of female labor occupation as a strategy of last resort in times of distress, due to women's usual time-intensive domestic responsibilities. This table reports the disaggregated results for higher labor activity. Each day of heat stress reduced male higher labor by each activity with no effects. So like heat stress reduced female higher labor by 0.03 to 0.11 days per hectare for land preparation and planting and weeding with no effect on harvesting. Our last table reports fixed effect estimates for total family labor for dual adult household and female-only household. While heat stress reduced male family labor by about 1.5 days per hectare, and no effect on female family labor supply. 1 day of stress is associated with a significant increase in female family labor by about 2.4 days in female-only households. Several factors may drive observed difference in responsiveness to heat stress. The first is related to gender difference in access to productive resource. As noted in previous studies, given women's limited access to agricultural resource, the heterogeneous effects of heat stress on female-only household and dual adult household are consistent with existing literature. The second is related to physiological sex-specific difference in body reactions to heat. I found this linkage interesting while talking to my former supervisor at FREE. Existing evidence demonstrates that females sweat significantly less than males, which possibly leads the latter to be more vulnerable to heat stress. The last possible explanation of gender-specific difference in heat responsiveness is related to the man's greater likely to respond to climate shocks through local or international migration and income diversification. Specifically, these constraints may result in women often bearing even greater workload burdens than men to mitigate weather shocks. Our findings could have implications for gendered policies on labor allocation, gender-specific development interventions and adaptation strategies are suggested to promote women's adaptive capacity. This can be designed to attain the sustainability Sustainable Development Goals called SDGs, especially SDG 5 and 13. For example, broadening of coping mechanisms and small-scale irrigations may improve women's adaptation to heat stress. While acknowledging the potential channels, further research and more extensive data collection are needed on the role of different pathways to heterogeneous response by gender under diverse environmental conditions, including extreme climate events. Also, we'll be able to do relevant empirical research using Women's Empowerment in Agricultural Index called WEA, launched by IFRI. This tool can be used to capture the role of ownership and perhaps more importantly, control of agricultural assets as well as workloads on gender difference in responsiveness to heat stress. By doing further research, we may know if the heat truly never bothered women. Thank you very much for listening, and please contact me if you have any questions. Thank you.